All right. Well, hey, y'all. Good morning, everyone. I am excited to be here. Thank you so much for joining this morning for JavaScript and Friends. I'm, you may think otherwise after you listen to some of my keynote, but I am a huge fan of JavaScript. I've been using JavaScript for a long time, um, pretty much from the beginning. And I think it's a fantastic language. Now, I am going to poke a little bit of fun at it. You know, hey, JavaScript's an easy target, right? But sit back, relax. I hope this is informative and entertaining, and I hope it's a great start to your day. So let's get started. Hello, I'm in recovery for type coercion, automatic semicolon insertion, and my name is David. Maybe you're like me and you've been burned a time or two by JavaScript. Um, JavaScript has caused many a developer more than a fair share of indigestion over the years. You know, we get burned twice in development and in production. Things happen in production that, we would have never imagined. Well, my first introduction to JavaScript was around 1997. At that time, I was a Visual Basic developer and I started building web apps with ASP, or as some would call it, classic ASP. I kept reading about people doing this thing called DHTML, dynamic HTML, and I wanted to learn how to make my websites more dynamic. Like dynamic cursors, alerts, rollover buttons, objects that bounce around on the screen. The more obnoxious, the better, right? You remember those days. Well, things started to really get serious just before the dot-com bomb in early 2000s. I joined a hot startup to build an interactive commercial web app, and I needed to support both IE and Netscape of that time. That was pretty challenging. And it seemed like so many cool companies were having great success with JavaScript or JScript in the case of Internet Explorer. I wanted to be a cool developer, but it was sure a struggle to learn. And there was a lot of trial and error. And with JavaScript, as you know, anything goes, and it often does. If you were a web developer around this time, you probably remember sites like Dynamic Drive. I spent countless hours trying to understand the JavaScript code I lifted from sites like dynamicdrive.com. And the JavaScript worked on their website, but when I pasted that exact same code into my app, I couldn't understand why wouldn't it work like it's supposed to in my application. JavaScript is amazing, except when it isn't. Quirks and weirdness in the JavaScript language continue to exist even to this day. There's unexpected behavior that can baffle even the most seasoned JavaScript developer. Let's talk about some of those. JavaScript has this special value named nan, which stands for not a number. So given this statement, if my clicker will work, given this statement, if any variable, let's say this n variable or the f variable, if it's nan, then the entire operation will result in nan. Sometimes it's very difficult to find because there's no clue given as to where this not a number may exist in any of your expressions. Well, what is NaN? How can you test for it to see if it's, you have one? Well, is NaN greater than or equal to 0? No, that's false. Is it less than or equal to 0? No, that's false. Well, what's the type of NaN? It's it's a number. Okay, so it's a number that's not greater than 0 and not less than 0. Yeah, it's sometimes the JavaScript language gives us some challenges, right? How are you supposed to know? Let's talk about math. Math in JavaScript can be fun at times. We in real math, we have commutative properties where we can have statements like A plus B, this is mathematically true. This should always be true. But in JavaScript, when we evaluate this kind of statement, it's not always predictable. Cases where it's true and cases where it's false. Well, for example, what if we do 0.1 plus 0.2? That should certainly mathematically equal to 0.3. No, not in JavaScript. Well, what is 0.1 plus 0.2? It's 0.300000004. Well, this is not just a JavaScript problem. This is a floating point math problem because apparently computers are hard and we still haven't figured out how to express floating point numbers. How long have we had computers now? I don't know. But then there's some really edge cases, right, in JavaScript that are pretty fun. Like you take this number and you use math.round and you get what you would expect. It's 0. But if you take another equally very large and strange looking value, and mind you, the only two differences between these two values is that very last digit. One is 2 and one is 3. That rounds up to 1. That's amazing. I've got 99 problems, but JavaScript ain't one. I don't know. I want to know who is the poor soul that discovered this problem. Like, what kind of scenario generated like, oh, well, it's down to that very digit. All right. So let's talk about sorting. So if we sort an array of numbers, we should get what we expect. Like, okay, what? JavaScript, is very useful. It's very, wants to help, right? So it translates those numbers to strings and then sorts them. That's cool, I guess. What if we use a function like map and we map all these numbers and parse those back to integers? Well, we should get an array of tens, right? No, we get, parse int doesn't work quite like we expect. It takes more than one argument and strange things can happen. Well, let's talk about duck typing. In JavaScript is a dynamic language, and there's lots of there are some types in JavaScript, and those are very useful to be able to use those types and to be able to figure out the types of variables that are in our code. So if we use the type of operator and we say type of undefined, we get undefined, which, hey, that's good. We can figure out what undefined is. If we say type of true, then we get something like a Boolean. That's what we would expect. Or type of string hello. That's a string, right? And then type of 1, that's a number. But what if we do a type of an object? and it's an object. Type of array, it's an object. Type of null, that's an object. Oh, great. So it's, the type system, even though there's some basic types, it's a little bit of a black art sometimes. So let's talk about null. If we use the number function to cast null, then we get 0. Okay, so internally, maybe null is 0 or it gets cast to 0. So let's do some of that type coercion type stuff, right? Is null equal to 0? No, is null greater than 0? Nope. Is null less than 0? No. Okay. Is null greater than or equal to 0? This one's true. What? Less than or equal to 0. That one is also true. That can lead to some really interesting things that can happen in your code. And then, of course, JavaScript has this concept of variables or values being falsy or truthy. That's part of the type coercion, magic that can happen. So obviously false can be false. Null is considered to be false. Undefined is false. Empty strings are false. 0 is false. Nan is false. So if any of these, land in your code somewhere, and it being dynamic, any of those can equal false. That can be fun. Fun time for all. And let's talk about regular expressions. That's a really powerful feature of JavaScript. But, you may have heard something like, well, I had a problem. I solved it with a regular expression, and now I've got nan problems. Well, let's look at an example of how regular expressions can trip us up. So we got WAT, which is a regular expression of testing for the letter A. And if we test the word JavaScript, yeah, there's an A in there. We get true. But if we turn around and we test another string, wait, what? False? There's an A in there. It turns out that that the regular expression, it maintains state, so that if we're testing multiple strings, different strings with the same regular expression, then fun times. So always use the same string or use different instances of a regular expression when you're doing those kinds of tests. Don't reuse regular expressions. And then there's syntax quirks in JavaScript, right? So if we have this statement and we have a function named troll that's returning what appears to be an object, what do we get when we call that function troll? We get undefined. What should, why is that? Well, that's because JavaScript, again, is trying to be very helpful, and it sees that return statement with, no other expression afterward, and it automatically inserts a semicolon for us. So here's one case where, yes, I am on team semicolon. Always end your statements with semicolons, and always keep your objects, curly braces starting on the same line. Those kinds of things. Let's talk about arrays. Arrays are dynamic, and that's really cool. We don't have to initialize them ahead of time like we have to do in other languages. We can just start stuffing things into arrays willy-nilly any way that we like. So if we have an array and we set index 1 equal to 1 and then 3 to equal to 2, there's no problem. We can just stuff as many things we want. So now we have 3 items in our array. And when we take array.length, we should get 11. Okay. that kind of makes sense. Arrays are zero-based indexed, and we put something at 10. So JavaScript obviously expanded that array to have 11 total elements for us. Good, I can understand that. But if we do something weird, like maybe there's a bug in our code that's stuffing things with odd values. So if we say array index of -1 is equal to 4, array.s equals to 5, what happens when we, are we now at 13? Or what kind of value should we expect out of array.length? It's still 11. I mean, I don't know. Why? How? JavaScript has been around for years. And, those of us in technology, we're pretty smart people most of the time, right? Why haven't we fixed these things? Why do these kinds of things still exist in the JavaScript language? How did this happen? JavaScript, arguably the most popular, most ubiquitous, most universal, most pervasive language in computer science history so far. If it's so important, why is it so terrible at times? Now, the birth of JavaScript is the classic example of how so many things get created in the software world. It's funny, but it's the kind of funny that makes you want to cry. So here's my dramatized version of how JavaScript was born. So here's Mark Andreessen. He was at the University of Illinois and was one of the people who created the first internet browser, the NCSA Mosaic. Mark moves to Silicon Valley and helps to start a little company named Netscape. February of 1995, Mark hires a man named Brendan. Here's Brendan. Brendan Ike. He was hired to create a scripting language for Netscape. The original plan was to implement Scheme, which is a dialect of Lisp, the infamous or famous Lisp language, which is, regarded by a lot of people as being really, really great. And Scheme is pretty great. Or so, some people's opinions are. So May 1995, Andreessen calls in Brendan and says, "Brendel Pants, we need a demo of that new scripting language like yesterday." "It's Brendan, sir. Sure thing. Scheme in the Netscape is going to be awesome." Scheme? Brandy Farm, you're hilarious. Scheme in the browser? No, seriously though, it's got to look like Java. Let's call it Mocha. Mocha, Java. Get it? And we need a demo by the end of next week. People aren't convinced that this thing's going to fly. I'm going to need you to come in on Saturday, okay? Sunday, too. So, you know what Brendan does? He does what any of us would do in this same situation, what many of us have done in our careers. He, like a heroic machine, through the nights and the mornings throughout each day, and then 10 days, 10 whole days, he delivers Mocha. The first version of JavaScript was created in 10 days. That's both incredibly amazing and absolutely horrifying. Good work, Boogaloo. Ship it. But sir, it's only a demo. I still need to ship it. Well, It's the most classic move in all of programming. Take the demo, ship it. Mocha was supposed to be for amateurs, right? And designers. Who cares if it's buggy? The real professionals, quotey finger real professionals, are going to be using Java. Java is the future. Well, plot twist. You know how that turned out. Java. It was supposed to be the language for the web. Write once, fail everywhere. It was a fun experiment. But Mocha, right? I mean, how did okay, well, it's there and it's easy to use. So let's look at a timeline from that point forward. So in, as we've talked about, 94 Netscape Navigator was created. Brendan Eich was hired and he created Mocha in 10 days in May of 95. In September of 95, they renamed it to LiveScript, and they didn't like that name, so they called it JavaScript because Netscape and Sun and Java and all that stuff was kind of getting mixed in together. Well, in 1996, Microsoft, they're paying attention. They're seeing what Netscape is doing, and they reverse engineer JavaScript for Internet Explorer. They can't call it JavaScript because at that time, and it still is really technically, JavaScript name is trademarked by Sun. So Internet Explorer, Microsoft, they call their scripting language JScript. They do such a good job of reverse engineering that they reproduce every single quirk and flaw, and it works identically. Kind of makes you think, Well, anyway, Netscape has seen Microsoft at work. The old Microsoft, how they would embrace and extend and extinguish, their competition. So they know that if Microsoft has their way, they'll run away with the language and either, seek to destroy it somehow. So, and, replace it with their own type of thing, good or bad. So in an offensive move against Microsoft, Netscape decides to standardize JavaScript. So they talk to the obvious candidate, the W3C. The W3C responds, no thanks. We have more important things to focus on right now, like the marquee tag or blink. Unfortunately, my little animations aren't working. There we go. So W3C has got more important things to do, like the marquee and blink tags that they're, hotly focused on. So Netscape goes to ECMA, the International Standards organization based in Stockholm, Sweden. And ECMA decides that they're going to take on this language, and they create a committee called the TC39, which is a technical steering committee. I guess it was the 39th committee to have been created in this organization, hence the name TC39. And they create a document named the ECMA 262, which presumably is the 262nd document they had created as a standards organization. And so ECMA 262 is the formal language spec for the JavaScript language. And since JavaScript is a trademark of Sun, they couldn't use the JavaScript name in their spec. Hence, we have ECMAScript. This is how we got the name ECMAScript. ECMAScript is the language specification. JavaScript, as it's found in browsers and other places, is just one of several implementations of that standard. So this happens around 1997, and 1998, we get ES2, which is basically some edits to the specification around ISO certification. Nothing really changes in the language. ES3 comes along in 1999 and adds features like regex, try catch, better string handling. Man, if we didn't have try catch before 1999, I remember those days. And then in 2009, we get ES5, which adds a whole bunch of features like strict mode to reduce some of that quirkiness in the language. We get JSON library support, reflection, and then ES6 comes along in 2015 and is another huge major update that includes classes and generators and arrow functions and promises and many other features. Oh, wait, hang on a second. Record scratch. What the crap? 10 years? It was 10 years from 1999 to 2009 before we got a new version of the language? Yes, it's true. If you were a web developer during this decade, it was a pretty tough time. You see, Microsoft won the first browser wars with IE6 around 2001, for better or worse, and basically sat back to watch the world burn. Microsoft won, but we all lost. By 2008, the standards, the TC39 had been working on an ES4, but by 2008, it was so big and complex, and there was no consensus among members of that standards committee. And for technical and political reasons, especially between Microsoft and Yahoo and Adobe, ES4 was abandoned. And ES5 came out of the ashes of some updates to ES3. What was supposed to be ES3.1, they renamed to ES5 and set that as the path forward. And then ES5 was referred to as Harmony to try to bring harmony back into the world of JavaScript. Well, interesting side note. During that 10 years, you may recognize this logo. Later, it was rebranded. But Macromedia Flash, back in those days, was a plugin that once dominated the web. People created amazing interactive interfaces and games and animation, all kinds of things with that plugin. In Flash, if you were building anything more than a cartoon, you needed to use its programming language called ActionScript, which looked a whole lot like JavaScript. That's because ActionScript was yet another implementation of the ECMAScript standard. So between 1999 and 2009, the developers at Macromedia, and then later Adobe, were early implementers of the proposed ES4 spec and were helping to push that language forward. By 2006, ActionScript 3 had classes, interfaces, a type system, enums, default function parameters, modules, and a package system. Flash developers may argue that what they had in 2006 is still better than what we have in JavaScript today. I think that's interesting. So let's take a quick look at a few of the other major milestones of the web that helped influence JavaScript. So as we talked about, we got IE6 around 2001. Firefox and Gmail come out in 2004, which had major impacts on web and web development. I'll talk more about Gmail in a little bit. jQuery, oh my goodness, 2005. up until this point, it was really hard to be a cross-platform web developer, right? Having to write code that targeted both Internet Explorer and Netscape, and even, a few others like Opera and whatnot. jQuery made such a huge impact on, all of us who were building browser applications, because now we have a single API that normalized all these differences. jQuery and its popular plugin community made web application development accessible, taking away a lot of pain. Not all of it, but a lot of that pain. Now web apps could be created by mere mortals like you and me. There were other frameworks out there, but jQuery certainly became the dominant solution. Gmail and Google Maps, that was also, Google Maps comes out in 2005. This took browsers applications to a whole new level, never thought possible before. They demonstrated to the world what a browser was capable of. And web developers now had this kind of new gold standard to try to create applications that were as dynamic and amazing as these applications. So 2008, Google Chrome comes out and takes the web by storm. Microsoft has been coasting on IE6 for years, and people are desperate for a better browser. Chrome adoption grows so quickly, it stirs up Microsoft to start releasing new versions of Internet Explorer. Much to, everyone's happy about that. Right? So ES5 Harmony comes out in 2009, and so does Internet Explorer 8, which becomes another, dominating, another strong force in the Microsoft tech community. And then around 2014, we get HTML5 and CSS3. There's a 15-year gap between HTML4 and CSS2, but that's another story. Whole nother set of drama. Let's go back and talk about that TC39. There were 10 years between ES3 to ES5. And it was another 6 years before we got ES6. The TC39 realized, they knew all along, that they needed to fix their process. But adding features to the JavaScript language is not a trivial task, because the first rule of the TC39 Fight Club is you don't break the internet. Backwards compatibility has always been one of the highest priorities when making changes to the language, which is why some of that quirky behavior still exists. It continues to exist on purpose. It's codified in the spec. Because if they fixed it, fixed the language, it would break all the code that expects that behavior. The internet would collapse and the world would explode. So I submit to you my hypothesis that the Death Star's superweapon was actually just a very powerful JavaScript emitter. I think that would do the trick. So the TC39 committee is made up of developers, implementers, framework authors, academics. The ECMA 262 document is currently more than 1,200 pages long. And since 2015, the TC39 has had a better process in place, meeting every 2 months or so. They meet for 3 days at a time, and all their discussions are time boxed. The entire process is open, and you can follow their progress through their repositories and their meeting notes. So to describe how a new feature comes to be in the JavaScript language, it has to make it into that ECMAScript standard. There's an idea that a feature request has to be moved through a series of stages. So at stage 0, we have what's called the strawman stage. And of course, the TC39 process is zero-based indexed, bunch of nerds, right? Good zero-based as God intended. So stage 0 is the idea stage, known as the strawman stage. And there's lots of new ideas that get submitted at stage 0. This is like throw stuff up against the wall, see what sticks. And then stage 1 is a formal proposal. It's an agreed upon first draft. The proposal essentially states what the problem is, how it might be solved, and some of the known technical challenges. At this point, a polyfill might be created as a proof of concept. A polyfill is like a JavaScript library that demonstrates how this new idea might behave or look in the language. A champion is selected from the TC39. I, imagine, champion with a shield and protractor. I don't know. So they take ownership of this proposal, and their job is to see it through the rest of the stages. So stage 2 is where the details are worked out. A formal specification draft is created. Things like syntax, semantics, backwards compatibility, all those things are fleshed out during stage 2. Stage 3 is the candidate, the feedback stage. The specification is finished, and this signals to the community that it's ready for real world usage and feedback. So browsers and other implementers of the JavaScript language may choose to add this new feature, maybe behind a flag or plugin. And this is where we see Chrome add new features to V8, which is their JavaScript engine, behind feature flags, so that, if you are inclined, you can enable those features and test them out and so forth. In Node.js, those feature flags are usually become command line arguments to the Node application so that you can test those language features. Now, a language proposal that gets to this stage, it's close, but it's still no guarantee that it will make it into the final version of JavaScript. Those that make it past 3 land in stage 4, and this is finished. It's the acceptance tests are added to a test 262 project. There's at least 2 implementations that pass all the acceptance tests, and it's ready for release in the next language spec. A PR is created for the ECMA 262 document, and the cadence that the TC39 has been on since 2015 is stage 4 selections are made in January, and the new additions to the ECMA 262 document is released in June. And that means this year, the final approval of ES 2020 was made June 16th, and the final spec was released June 17th. For those of you who may not be up on 2020, because man, what a 2020 we've had. Why do we need, maybe we should have took the year off adding new features to JavaScript, but there's some cool things. There are basically 7 new features in JavaScript this year in ES 2020. There's optional chaining, which allows you to safely access deeply nested properties. So imagine you have an object. In the past, if you wanted to get to the city or the state, you would have to test every property along the way. With the optional chaining, you can use the syntax with the question mark. And now, if, say, for instance, user 1 is null or address is null, it's not going to blow up. Really cool. We get nullish coalescing, so that instead of just using the double pipe to check any kind of null, falsy value, we can test specifically for null or undefined and get a default value if it is. There's a global this object now. So regardless of what environment you may be writing JavaScript for, whether it's the browser or Node.js or a web worker, you now have a consistent way of getting to the global scope. There is a new promise.all settled, which is, instead of like promise.all that will, if something is rejected, it stops immediately. All settled will will be called after everything has been complete, regardless if a rejection has been thrown. We get dynamic imports where we can have import statements, and we use async and await to load those modules dynamically. That way we don't have, if we never have a click event happen on an application, we never have to worry about loading up that module, right? That could, these are optimizations. There's also a match all, which is, to do the equivalent in regular expressions with all the things, it's a lot of work. And so match all is a huge improvement to regular expressions. And then finally, we have big int, which is bigger than, the largest integer value that we could have in JavaScript was 2 to the 53rd minus 1, some kind of huge number like that, and which was a constant on number called max safe integer. But now, arbitrarily, we can have arbitrarily large numbers. Theoretically, it can be as large as anything. So big int can help, some scenarios where we need really, really big numbers. Okay, so despite the weirdness and warts of JavaScript, there are amazing things that continue to be created with the language. We've talked about Google Gmail, Google Maps, Google Sheets that kind of set the stage for what's capable. We've learned in recent years that NASA is using Node.js to help analyze spacesuit data to make astronauts more safe. JavaScript in space, well, that's a pretty bold move. Hey, if it's good enough for NASA, well, one little part of NASA, but that's good for us. Jeff Atwood, famous law, any application that can be written in JavaScript will eventually be written in JavaScript. This self-fulfilling prophecy is no more true than the emulators that you can find that are written purely in JavaScript, like DOS and Linux, Commodore 64, and Lord help us, an entire Windows 95 running in Electron. There's so many other things that you can do with JavaScript. IoT, you can create music, you can create games, you can create desktop applications with like Electron, Visual Studio Code, GitHub Desktop, and the Slack desktop apps are all examples of creating applications with Electron, which is essentially Node.js and Chromium for rendering. And, we're just scratching the surface. Mobile apps, automation, command line apps, services, anything and everything we can imagine, we can create with the JavaScript language. I think that is extremely powerful and amazing. Makes me feel good that even though I have spent a lot of anguished time fighting the JavaScript language, that I can use that as a tool to do anything I can imagine. Okay, so JavaScript can be challenging, but it's getting better all the time. Here are some of my thoughts on the future of JavaScript. So in the life of JavaScript so far, we've seen the language evolve and be influenced by a number of other languages and libraries and browsers, things like jQuery that heavily influenced the browsers and things to adopt new standards. And we're seeing some new things come along that are influencing the JavaScript community. Things like WebAssembly. One of the questions I get asked is WebAssembly going to replace JavaScript? Well, here's WebAssembly. What it is a portable binary format for precompiled code running at near native speed. Has great potential. It can be compiled from languages like C, C++, Rust, Go, Python, C#, Java. It's an alternative for executing code in the browser. And one of the reasons it's so fast is that the JavaScript engine can skip the normal compilation and optimization steps and go directly to executing that code. WebAssembly only supports 32-bit, 64-bit integers, floating point numbers, and it's a low-level assembly stack-based system. It's good for CPU-intensive work like image and video editing and gaming, image recognition, artificial intelligence. What it's not is a replacement for the JavaScript engine. It requires the JavaScript engine to run. It's designed to complement JavaScript, not replace it. But WebAssembly has no direct access to the DOM or can, do those kinds of things that JavaScript can do. Another thing that's come out recently is Blazor. You may have heard, which is a way to create single page apps using .NET, C#, and Razor templates and get deployed as a mix of WebAssembly and JavaScript interop. It's an abstraction that some .NET developers seem to be really excited about. Now, it might not be a fair comparison, but all of this reminds me of the new Silverlight. Instead of being a plugin, it takes advantage of WebAssembly, which is better. But some niche apps may take advantage of it and really take off with it. But like Flash, Silverlight, and other attempts to abstract the web, I personally don't see it as a sustainable alternative to just good old HTML, CSS, and JavaScript. If you're a .NET developer and you already hate building web apps, using Blazor is probably not going to change your mind. It's just my opinion. And then, of course, we've seen in the last couple of years, TypeScript has gained momentum, and TypeScript does seem to be becoming the standard for a type system for JavaScript. If you listen to the TypeScript believers, you might be convinced it solves all of JavaScript's problems for all time. Well, Eric Elliott, a well-known author and speaker and open source developer in the JavaScript community, he wrote a blog post called The TypeScript Tax, a cost-benefit analysis. Contrary to a lot of the hype that's out there, Eric says that TypeScript projects that he's been a part of have experienced more friction and more time onboarding, and argues that the type system only prevents a small percentage of bugs. The bigger, more costly bugs can't be prevented by a type system. Well, newsflash, turns out that a language, whether it's dynamic or static, can't save you from making mistakes. I recently had a conversation with a developer who said that after 2 years of using TypeScript, he wishes his development team could just go back to using plain JavaScript. Still, I recognize that there are some benefits. You may be using TypeScript today and having great success. I can recognize that for large projects and large teams, TypeScript provides some value. I find it interesting that members of the TC39 are using TypeScript and are vocal about it. My prediction is that we may start to see some of those most valuable ideas in TypeScript begin to make their way into ECMAScript specification. If that happens, will there continue to be a strong case for TypeScript? If we get, the very best bits of TypeScript in ECMAScript, will we really need to use TypeScript? Time will tell. What I do know for sure is that regardless, I believe that there's a strong case to be made for investing in JavaScript. The good, the power, the flexibility, the fact that it's everywhere, those things far outweigh any of the negatives. The language has improved tremendously in recent years, and I believe it's only going to get better. Thank you, JavaScript, for enriching our lives, for keeping us on our toes, and for making us humble when we're tempted to believe that we have it all figured out. Last of all, I believe all of us in technology have an incredible opportunity and responsibility to make a positive impact on our workplaces, our community, and the world. I challenge you to take the things that you're learning today, share your experiences with others, and help make our world a better place for everyone. So wherever you are, I hope you stay safe. Cherish the time that you have with your loved ones. Make the most of the gifts and the talents that you're blessed with, and you get out there and be awesome. Thank you.
Thank you, David, for the great inspiring talk and keynoting our second year.
You're welcome. So if there are any questions, for the next few minutes, I'll try to get on Slack or wherever and answer any question that you might have. I'm Reverend Geek everywhere on social media. If you want to email me, I'm david@reverendgeek.com. Glad to help in any way that I can.
Thanks, David.